All right, it's time for number 3. How long do the longest 15% of pregnancies last? Okay, here comes your normal distribution. Okay, the longest 15%. So first of all, the mean, which I believe was 266 days. All right, that part hasn't changed. So 266, don't forget your units, days. And we want that longest 15%, y'all. So the longest 15% is going to be definitely somewhere on this side of the mean. All right, so because it's saying the longest 15%, that's the top 15%. So we will shade in this area. Okay, so we are looking for this X value right there. That's our goal. We're not ready yet, but let's go ahead and draw our z-score picture, which will be incomplete for a moment, temporarily. Okay, all right, the mean of a z-score distribution is always 0. And let's label it z-scores. Mandatory, you must put that. Okay, and we're going to want the same type of a deal as this X over here. Okay, but this is a z-score that we are looking for. But it's still the top 15%, so we will still shade this and call it 15%. Oh yeah, I should label this also. This red stuff, that's 15% of the data. So let's find X and let's find Z. So we're going to do these calculations in a minute, but here's the problem, guys. We cannot use this 15%. Again, we cannot use this 15%. When we use our z-score chart, the chart is only giving us probabilities to the left of Z. It's got to be to the left, not the right. But as you can see, all right, this value, this 15%, is to the right. So we have to ask ourselves that extra question. If there's 15% to the right, that's fine and good, but what is the percent to the left? Okay, in other words, what's the percent from this here direction? Okay, and this percent is going to be 85%. Okay, so 85% of the graph is to the left of this number. So you have to use the left side, so we'll use the 85. Okay, so fine and dandy. So we will use our 85%, and as a decimal, 85% equals 0.85. Now I'm going to go ahead and write 0.8500 to make it the same length as all these lovely values. All right, so let's hunt for 0.8500, or as close as we can get. All right, there's 0.8531, 8508, 8485. Okay, so 0.8500 is going to be somewhere between these two numbers. Okay, 0.8508 is closer than this one, so let's go with that. All right, now looking at what z-score that implies. Okay, and I can get rid of these old ones that we're not doing right now. So looking at 0.8508, the z-score that goes with that is 1.0 and then 4, 1.04. In the meantime, 0.8508. So 0.8508 is closest. So that tells us that our z value is 1.04. Is that right? 1.04. Okay, so that's great. Now that we know that, well, first of all, with the z-score, we have found this. So let's go ahead and put it where it goes. So the z-score is 1.04, which, by the way, that means this is one standard deviation above the mean. Okay, now that we have the z-score, we can use it to find x. All right, what I'm saying is we are all familiar with the formula where z-scores come from. All right, it's our value minus the mean divided by the standard deviation. If the z-score is 1.04, this becomes 1.04 equals the x value minus the mean, which is 266, divided by the standard deviation, which was 16. I can see it from the previous problem. Okay, so if I solve this, I found x, and really I'm done at that point. So I would solve this by multiplying both sides by 16. That way these cancel out. Okay, so 16 times 1.04, 16 times 1.04, that is giving me 16.64 is equal to x minus 266. All right, now we add 266 to both sides. All right, so plus 266. And that gives us 282.64. And that is really the answer. Okay, let's go ahead and put that value in now that we finally found it. Okay, so this value right here is, in fact, 282.64. Okay, so this is what your pictures should look like, guys. Just like these. Okay, so remember that number, 282.64. In the final box, we will answer with a complete sentence. So I find it helps to read the question and reflect it back as your answer. So how long do the longest 15% of pregnancies last? So listen how I incorporate the question. Okay, the longest 15% of pregnancies last over 282.64 days. And there you go. All right, so that was number 3, I believe. Let's move on to number 4. See what's going on. Okay, we have a new problem, new situation. This is all about IQ scores. I see my mean of 110 and my standard deviation of 25. Okay, file that away. So, number 4, what scores fall in the top 60% of IQ scores? Okay. Guys, please don't copy off of me, by the way. I have a feeling some of you are just copying, just shamelessly copying off of me. You might not even hear my voice right now because you're just fast forwarding and copying the actual images. But you will not learn that way. And when the test comes, you'll be sorry. I don't know what that was. Let's see, the mean is 110. So let's put that down. And okay, now the question. What scores fall in the top 60%? Okay, well, we know that this is the top 50% on the right-hand side. So the top 60% has got to be a little bit bigger than that. So let's see, I'm going to put it about here, say. Okay, so the top 60% is going to be everything to the right of this line. Okay, and let's label this, so this is supposed to be 60%. Okay, again, make sure you label this as IQ scores. And then similarly over here, the right-hand side is 50%. So again, 60% has got to be bigger than that. Okay, so there is your 60%. Make sure you have this labeled as z-scores. All right, so we are going to look for this z-score, all right, right here, and which will in turn give us this x value. Okay, now the question is, guys, am I going to use this 60% directly, or do I need to find a different related percentage? Yeah, I need to find a different related percentage. I cannot use the 60%. The reason why, I want to be able to use my table of probabilities, but the probabilities are always for the area to the left, all right, the probability below z. This is above, so that's no good. So you have to make sure you're always using the value below. Okay, so obviously if this part of the distribution is 60% on the right, then the rest of it, the part to the left of x, must be 40%. All right, and we'll have to use the 40 because we always have to use the left part. Okay, so here I go then. So using the 40%, like I said, 40% equals 0.4. Move it twice. I'm going to go ahead and call it 0.4000, so it's the same length as the values on my chart. Okay, now I'm going to try to find as close as I can to 0.400. This is on the negative side of the graph, so I need to be on the negative side of the chart. Let me see if I can delete some of these. So get to the negative side, you guys. Okay, negative 0.4. Okay, so here's negative 0.3, negative 0.4. Let's see. Okay, here's 3.9. Okay, here it is. It's right in between these two values. So which of these is closer? All right, ignoring the decimal for a second, ask yourself which one of these is closer to 4,000. This is 13 away, okay? Whereas this, you know, if it were 80, it'd be 20 away. But so this is like 26 away. Okay, so this is closer. So 0.4013. I'll delete this highlighting. 0.4013 is the closest. So just write that down. Is closest. And that is going to give us our z-score. Looking to the left, I have negative 0.2. All right, negative 0.2 what? All right, looking above, that's negative 0.25. So z is equal to negative 0.25. Okay, now I can go ahead and do my calculations. Let me go ahead and record that z-score now that I know it. So now I know this z-score, so write it in. All right, this is negative 0.25. Okay, so that's very close. Anyway, the calculations. We know that the z-score is equal to the value minus the mean divided by the standard deviation. So put the z-score in. So I've got negative 0.25 is equal to the value minus the mean, all right, divided by the standard deviation, which I believe is 25. Should check. Yep, there it is. All right, I will solve this by multiplying both sides by 25. Okay, 25 times negative 0.25. 25 times negative 0.25. That is negative 6.25. These cancel. So that equals x minus 110. Time to add 110 to both sides. So plus 110. That's going to give me 103.75 is equal to x. Okay, that is really the answer. Let's go ahead and record it on our picture as well. Okay, this is 103.75 right there. So, time to write our sentence. They wanted to know what scores fall in the top 60% of IQ scores for this age group. Okay, so we will write the top 60% of IQ scores, and let's mention the age, for ages 20 to 34, are above, okay, what was it again? Above 103.75. And that is how you do that. All right, it's time for class to start, so I'm gonna have to stop this video here. And I probably won't be able to make any more videos from this assignment. So I hope that's enough to get you started, and you should be able to do number 5 and 6 on your own.
Mr. B, did I get in it?
You're in it. That was Aaron, by the way.